Hello, welcome to JavaScript tutorial, chapter 22, different ways of defining JavaScript functions, brought to you by Ankpro Technologies. My name is Harish. In this session, we are going to learn about how do you define a function in different ways. So, this is what we learned in the last session. Like, we have defined a function called multiply numbers, and it takes two parameters, and this function, or it is doing like set of work, it is multiplying the two parameter values and it is returning the result variable, and this result variable which holds the value of this multiplied numbers. And in my seventh line, what I'm trying to do is I'm trying to call this multiply number function, and I'm passing the parameters, and I'm attaching this method to a variable called multiply, and this document.write is going to print the result on the web page. So this is what we learned, like how to define a function and how to call a function. So this is not that special. So let me jump into the next slide. And here we have something called function hoisting. So keep in mind, by default, the JavaScript moves all the function declarations at the top of the current scope. This is called function hoisting. So what do you mean by this? So let me jump into Visual Studio Code and let me show you a demo of this. It's very simple. So here comes my Visual Studio Code and here is my script tag. So what I'll do is first let me define a function, and the function name is multiply numbers. Okay, it takes two parameters, that is first number, comma, and it takes the second number. Okay, these are the two parameters. So what this function is going to do, it's going to create a variable. Let me create this variable, and it's going to take the values from these two parameters, first number, and I'm going to multiply. So it's second number. Okay, and it's going to return the result variable which is holding the value of the two multiplied numbers. Okay, now how do I call this function? It's very simple. So I can call it directly by multiply numbers, and it takes two parameters. You can observe here first number and the second number. So let me pass 10 cross 10 comma 5. Oh, my number lock is off. So yeah, 10 comma 5, and here ends it. So let me store it in some variable like multiply. The variable name is multiply, which holds the result of this function. So let me write it on the web page with the help of document.write method. Let me pass multiply to that, which is holding the result. Okay, now I need to execute this web page, so I have stored it in this folder. When I double click on that, it's navigating us to the Chrome browser. There we'll get the result of this, that is 10 cross 5, it's 50 on the web page. It's very simple. So where is my Chrome? It's opening. Let's wait for that. Yes, it has opened, and you can observe it writes 50 on the web page. You can observe here. Okay, it has written the result on the web page, that is document.write. We have passed the multiply number, so it's printing 50 on the web page. So this is what we learned in the last session. Now there is a concept called function hoisting. What is this function hoisting? By default, JavaScript moves all the function declarations at the top of the current scope. This is called function hoisting. So what I'll do is, here you can observe in this code snippet, okay, we have a function, okay, your multiply numbers, but I'm trying to call this function above the function definition. I've defined my function here, but I'm trying to call it in my second line, in my first line. So is this going to execute? Yes. Why? Because JavaScript follows some concept called function hoisting. By default, the JavaScript, it moves all the function declarations at the top of the current scope. Okay, so what happens is, when you in the runtime, the JavaScript, what it does is it just pushes this function definition at the top of this multiply. In the sense, in the runtime, this function is going to lie, or it's going to stay at the top of this declaration. Okay, before this line, it's going to jump there at the runtime. So that concept is called as function hoisting. So this is the reason JavaScript functions can be called before they are defined. So you can observe here, I'm calling this function before it is defined. It's defined in my fourth line, but I'm trying to call it in my first line. So this works fine because it follows something, the concept called function hoisting. So at the runtime, what it does is it just pushes this method above this line. So JavaScript functions are executed. So let me show you a demo of this. So what I'll do is I'll just cut these things and I'll paste before the function definition. So you can observe here, I'm trying to call my function in my 7th line, but the function is defined in the 10th line. So at the runtime, this piece of code, okay, what will happen is it just goes and sit here. So I'm cutting this. At the runtime, this piece of code, it goes and lies in this format. But let me keep it down just to show you a demo. Control S. Let me go back and let me refresh, and this still works. You can observe here I'm refreshing my web page and this still works. Okay, this is what the concept of function hoisting is. So coming to the next concept. So you can define JavaScript function in two ways. One is the standard function definition. So this is what the standard function definition. We are defining a function with a keyword, with the name of the function, parameters, and I'm calling the function in this manner. This is called standard function definition. And also we can define the function in another format, that is function expression. So what do you mean by function expression? A function expression allow us to define a function using an expression. So what do we do is typically we assign this function to a variable. So this way of calling or defining a function, okay, assigning a function to a variable is called function expression. So in function expression, we have three different ways of defining a function expression. So what are they? Anonymous function expression, named function expression, and self-invoking function expression. So let us understand the anonymous function expression. So what do you mean by anonymous function expression? It's very simple. So let me expand this piece of code. So JavaScript allows us to define a function without any name. This unnamed function is called anonymous function. You can observe here in my example, I'm having a function. I've defined a function. Okay, in the standard function definition, what we used to do is we used to define, we have to call this function keyword, and immediately we have to name the function. Right now in this piece of code, you can observe we have only the function keyword, but we have not named the function. So what do we call this type of function? This type of function is called as anonymous function. That's what the meaning of this sentence. JavaScript allows to define a function without any name. So this function does not have any name, so this function is called anonymous function. And the rule is, if you're defining anonymous function, anonymous function must be assigned to a variable. Okay, and let me show you that it's very simple. So let me jump here. So let me take this example itself. Let me cut this and let me paste it here. So what I'll do is I'll just remove this function name. So now it becomes an anonymous function. So keep in mind, anonymous function should be attached to a variable. So I'll take a variable and name it as demo. Okay, I'm assigning a anonymous function to a variable, and this works fine. Okay, you can observe here. Now how do I execute this function, anonymous function? It's very simple. I have to call that function with the variable name followed by this. You can observe here, as soon as this anonymous function is attached to this variable, but this variable will act like a function now. And you can observe here, when I type demo and when I open the brackets, you can observe here this demo variable is taking two parameters, that is firstNumber and secondNumber. So it is working this anonymous function. Okay, it has attached its functionality to this variable, so this variable will act like a function. Okay, and it takes two parameters and it executes this function. So let me pass 10 comma 10. So the 10 cross 10 is 100, and let me store this in some variable. So let me write it on the web page, the help of write method, which is present in the document object. So its result. Okay, now when I do Control S and let me push this code to the browser, and here we have to get 100. So this is what we call anonymous function. Anonymous function does not have a name, okay, and it should be attached to a variable, okay, and that variable will act like will do the work of this function. So it takes two parameters and it does the job of this function. And you can observe very clearly, functions defined using a function expression are not hoisted. So in the last example we saw, like, okay, you can observe here in the standard function definition we are defining the function here, but we can call it before itself. But this hoisting concept is not applicable for the function anonymous function expression. So that's what the meaning of this sentence. Functions defined using a function expression are not hoisted. So let me show you a demo of this. So here comes. So what I'm trying to do, I'm trying to call this function before it is defined. So I'm calling the function in my 7th line, but it's defined in the 10th line. And here, keep in mind, the JavaScript hoisting concept does not works. So let me go back and let me refresh. You can observe we are not getting the output. So let me inspect it. and let me check it out on the console. We have an error, you can observe here. So what is the error? Demo is not a function. So this is what you cannot apply the hoisting concept to the function expression, that is anonymous function expression. So that's the meaning of this sentence. Functions defined using a function expression are not hoisted. So I hope you understood what is anonymous function expression, and you have to follow these rules when you define anonymous function expression. And anonymous function expression, it has wide advantages. Okay, so let me go to the next concept, that is next type of function expression, that is named function expression. So this is similar to anonymous function expression. The difference is, instead of assigning the variable to an anonymous function, we are assigning to a named function. Now you have to understand this sentence very clearly. The difference is, instead of assigning the variable to an anonymous function, we are assigning to a named function. You can observe here, this method looks very similar to the standard definition. It's having a function keyword and as well as the function name, and it takes parameters, but still we are attaching this function to a variable. So this type of creating a function name standard function, and if it is attached to a variable, it's called named function expression. So this syntax, this named function expression, is mainly used for creating the recursive functions. So let me take an example of this and let me explain you how it works. So you can observe here, we have a function. This piece of code, what it does is it computes the factorial of a number. So the method name is compute factorial, and we are passing a number parameter, and here we are telling if number, okay, is less than or equal to 1, return 1, else, okay, return number into, that is multiplication, into compute. So what I'm trying to do here is I'm trying to call this method, the external method, again here. Okay, a method calling the same method. Okay, it's called, and what we are doing, it's trying to subtract from the number what we passed. So this type of method is called as recursive method. Okay, it's used for creating the recursive functions. So, and here you can observe, okay, if it is a named function, we can call directly with its name. Okay, but instead of that, we are attaching that to some variable factorial. We are passing a number and we are attaching to that variable result, and we are printing that result. So what is the problem? Keep in mind, the name of the function here in this example, the name of the function compute factorial, this function is not available outside. In the sense, I can't call a function with its name. Okay, it's available only within the same function. You can observe here, I'm trying to call this method within the same function. So this is available only within this function. So if you use compute factorial method outside the function, so I'm trying to call this compute factorial method outside the function. Okay, what it does is it rises the compute factorial is undefined. We'll get undefined error. So at this point of time, so what I'd like to tell you is, if you're creating a named function expression, you have to attach that to a variable, and you have to call the method with that variable itself. So what I'll do is, let me show you a demo of this. It's very simple. So let me erase these things out. So let me take a factorial and let me define a function. The function name is compute factorial. So it takes a parameter like number. So here is the piece of code, you can observe very clearly. If number is less than or equal to 1. So where is my, yes, if number equal to 1, what it has to return is, it has to return 1, else it has to compute the factorial of that number. So how do I compute the factorial? What I need to do is, I need to take the number parameter, then multiply it with the same method, but we have to pass the parameter like number minus, not a parameter like that, number minus 1. So let me go and do it. Return number into compute factorial number minus 1. So this is going to compute your factorial of a number. So let me go back, and this is piece of code. Now what I'll do is, I'll try to call this compute factorial method directly. So here is my, let me remove this as of now. Okay, what I'll do is, I'll try to call that compute factorial. So here I'll pass a number. So let me assign that to some variable. Let me alert it by just telling like taking that result variable which is holding the result. So when I do Control S, let me go back and let me refresh the web page. Okay, here we're getting 720. Oh, but what I'm trying to do here is I'm trying to attach that to this variable. So instead of doing like this, let me tell you like let me store it in some variable here itself. Alert result. So let me try to call this method outside the function. Let me pass a number to it. So let me go back and let me execute. Okay, you're getting 2 and it's like not a number. Okay, it's going to execute until that 6 get terminated. But keep in mind, if it is a named anonymous named function expression, what we have to do is we have to attach that to some number. Okay, then we have to pass that. So instead of doing like this, let me just tell like return this. Do we inspect it? Do we get any error? No, we don't have any others. So what I'm trying to tell you is, if it is a named function expression, first attach it to a variable. Okay, then what I have to do is where result is equal to call that factorial, or it's very simple, like let me call it directly with its name. Okay, factorial. So I'm passing 6 to it. So let me alert it. So what is a factorial of 6? It's going to compute it. So let me go back and let me refresh. We're getting it 720. So this is how the name function expression works. Okay, this syntax is useful for creating the recursive functions. Okay, and coming to the next concept, it is self-invoking function expression. So what do you mean by self-invoking function expression? They are called with the different names. That is immediately invoked function expression, self-executing anonymous functions, and self-invoked anonymous functions. So it is a function expression that automatically invokes after the completion of the definition. So here is an example for that. Okay. I've taken the same example of computing the factorial. So it observe very clearly, okay, this function compute factorial is enclosed within this common brackets, and immediately after that we are passing something within the common brackets, the parameter value, this number value 6. So what happens is how it is going to execute. So as soon as it executes from this common bracket to this common bracket, it justifies like the definition is finished. Next, if I pass within this common brackets the value, okay, it's going to compute like I'm calling this function. Okay, it's going to take the 6 number, the value as this number. Okay, and it's going to execute. So this function is invoking itself, so it's called a self-invoking function expression, or this function is calling itself. So how do I execute this function? It's very simple. So what I need to do is I need to enclose this. Okay, I need to enclose this function within the brackets like this, and after that what I need to do is I need to call, you can observe here number any, I'm going to pass the 6. Okay, what I need to do is I need to just alert that factorial variable which is assigned, which is having that function expression, sorry, self-invoking function. So alert factorial. Let me go back and let me refresh. Still we'll get the output as 720. So what do you mean by self-invoking? It itself will call the function. You have to just pass the parameter value. and from year to year this is a self-invoke function expression. Okay, and here we are calling the function by just passing the parameter value, and it executes itself and it stores the value in this result, and we are printing that result on the web page. So this is what we call self-invoking function expression. It is a function expression that automatically invokes after the completion of the definition. So what we learned in this session is we learned like different ways of defining a function. That is, one is standard function definition and other one is function expression. And in function expression we have three different ways. They are anonymous function, named function, and self-invoking function expression. So this is what about the different ways of invoking a function or defining a function. So that's for the day. Thank you for listening. Have a great day. Please subscribe to our YouTube channel Ankpro Training. You can also like our Facebook page visiting this URL. You can also follow us on Twitter. For further reference, refer our website. We're on LinkedIn too. Last but not the least, please don't forget to give the feedback. Thank you. Have a great day.